Hi, in this video we're going to talk about standard deviation, variance, minimum, maximum, skewness, kurtosis, and summary statistics. Standard deviation is how spread out numbers are from the mean, whereas the variance is the average of the squared numbers from the mean. We can look at an example called student heights, which can be downloaded from histogramma.com/data. So let's go ahead and go to data, which is right here, download student heights, open that file up, enable editing, and we have a very small 30-point data sample. So it's very easy to calculate the standard deviation and the variance, and I'll show you how to do that right now. Simply enter in equals stdev dot s for standard deviation sample. Open parentheses, enter in your first data point, which is A1, colon, through A30, which is the last data point, close your parentheses, and then hit enter. So your standard deviation is 4.38, which means the spread of the numbers from the mean is 4.38 standard deviations. To calculate the variance is similar, so we hit equals var dot s, open parentheses, your first data point, which is A1, through A30, close your parentheses, hit enter, and your variance is 19.22. The variance is simply the square of your standard deviation. So if you just take the square root of your variance, you will get your standard deviation. So for this sample, the standard deviation is 4.38 and the variance is 19.2. Let's move on to learn minimum and maximum. Minimum and maximum are self-descriptive. It's the minimum value of your dataset and your maximum value of your dataset. For this example, we can find the minimum by eye, possibly. It's only 30 data points, and it looks like the minimum would be 60, and the maximum would be 79. But to be sure, let's check using Excel. So in cell C1, enter equals min A1 through A30, hit enter, and the minimum was 59, so it's better off using Excel to calculate your min and your max rather than by eye. And then your max is done similarly, so max, open parentheses, A1 through A30, hit enter, and 79, so I was correct about that one. What if we have a larger data set? So let's go ahead and download a larger data set. So let's go to histogramma.com under data, and let's download diabetes 2005. Let's open that up. Wait for it to load. There we go. Enable editing. And here we have a large data set. So we have the header as percent. So these are the percents. So what if we wanted to know the minimum percentage and the maximum percentage? Obviously, it's a little bit too cumbersome to go through it by eye, so let's do it with Excel. So let's go in here and enter equals min A1 through And let's see what the largest one is. I'm sorry, the largest cell. So it's 3220. So it will be A3220. Hit enter. So the minimum value is 3%. Likewise with the maximum, max A1 through A3220. And your largest value is 17.7. So it's very easy to get your minimum and maximum, especially with a large data set. Next, we will talk about the skewness and the kurtosis. The skewness. What is the skewness? The skewness is how much data is concentrated above or below the mean. So if we look at this histogram and we look at it as a distribution, in which it is, we look at its symmetry. So you want to see, basically at the peak, does this half equal this half as far as symmetry? So sometimes it's hard to do by eye, but we want to know as far as a value. So we will check that using the skewness feature. So let's go ahead and type in here equals skew, open parentheses, A2 through, I believe it's 3220, A3220, close parentheses, and enter, and we have a skewness of 0.44. Now this value is positive, so that means that this is positively skewed, which also means that it is skewed right. So that means that we can see that there is much less data on the right side, less concentration, so it's more concentrated on the left side. So therefore it is a skewed right distribution. Let's look at a negatively skewed or left skewed distribution. Let's look at this histogram. We can clearly see that it's not symmetrical. There is more skewness on the left side. So this would be a negatively or left skewed distribution. Let's figure out what the actual value is. So we enter equals skew A1 through A3141. Hit enter, and we get a negative value. That is negative 0.37. So we can see that it is a negative skew, or left skewed, and it's not right skewed. So that means that we have a concentration of more data points to the right side of the distribution. Whereas on this one, we had a positive number, which is right skewed, or skewed right, positive skew, where we had more concentration on the left side. Skewness can tell you, again, how distributed the data points are within the histogram or the distribution. Very simple to calculate, and it comes in handy to know how well your distribution is oriented. Now let's go ahead and talk about kurtosis. What is kurtosis? Kurtosis is simply the measure of the peakiness of the distribution, which is this point right here on the histogram or distribution. The more concentrated the data points are toward the middle or the mean, and where these points are more squeezed in together from left and right sides, the point will be squeezed and rise higher. So a nominal or normal kurtosis will have a value of 3. So what would this histogram or distribution have for a kurtosis value? We can do that simply using kurtosis, which is typing in equals kurt, open parentheses, A2 through A3220, close parentheses, and hit enter. So this histogram or distribution has a value of 0.89, which is close to normal. This distribution, this histogram, let's try that. So equals kurt, open parentheses, A1 through A3141, close parentheses, enter. So this kurtosis has a value of 1.94, which is even closer to our normal peakiness or kurtosis. Next, we're going to talk about summary statistics. And in summary statistics, we can gather as many descriptive statistics as we can, including min, max, standard deviation, variance, skewness, kurtosis, and various other statistics that Excel provides. So let's start off with this example, diabetes 2005. If you haven't already done so, you can download it from histogram.com/data called diabetes 2005. And also obesity 2004. We'll be working with both of these examples. So let's go ahead and start with this one. So first, let's click on a blank cell, as I have done here. Let's go to Data, Data Analysis, and we want to select Descriptive Statistics. Click OK, and then it will ask you for your input range. So our input range would be, for this example, A2 through all the way down to 3220. Or you could have just typed it in. It doesn't matter. Then we want an output range. We want our output range to be on P2. So let's click in here and then click on P2. Then we want to select summary statistics, because that's what we're talking about. So once you select that, click OK. And then now you have a table of your summary statistics. So we have here mean, standard error, median, mode, standard deviation, sample variance, kurtosis, skewness, range, min, max, sum, and count. The purpose of summary statistics is to gather all information you can about your data set, and so you don't have to calculate each individual descriptive statistic one by one. You can get them all simultaneously using summary statistics. So let's use the other example, obesity 2004. Let's do that again. So we go to data analysis, descriptive statistics, click OK. Select your data range. Here would be, let's see, from A1 all the way to A3141. Then we want our output range to be P2, which is correct, and just click OK. And here's a table of descriptive statistics. You have your mean all the way down to your count. And that is all for descriptive statistics. You can get more practice using any of the, or most of the data sets on histogram.com/data, and you can get more practice that way. Thank you for watching.